Hello, welcome back. I am cnix. In this video, I will present the third story of Pascal, which is the AI-based digital twin system of cnix. Now, I will talk about solar radiance prediction for solar power generation systems, which is a key pillar of renewable energy. While solar radiance is generally not included in standard weather forecasts, but as far as I know, there are a few numerical models offer solutions to predict it. In solar power generation systems, being able to predict solar irradiance in advance can provide tremendous benefits to the renewable energy market. For example, the first, maximizing renewable energy efficiency. Since solar power generation is directly dependent on solar irradiance, the more accurate the prediction, the better estimation of amount of power generated in advance. This reduces uncertainty in power supply and makes energy planning much easier. The second, stabilizing energy supply and demand. By anticipating solar energy output, people can optimize the charging and discharging of ESS to balance supply and demand. It helps prevent the power shortages and reduces unnecessary overproduction. The third, optimizing energy pricing plans. Electricity prices can become lower during periods of high solar irradiance, making it possible to implement dynamic pricing models effectively. Consumers benefit from more economical and flexible pricing schemes. The fourth, activating energy trading. With the accurate prediction of solar power output, homes and businesses can plan their production and sell excess electricity more efficiently. This supports the development of microgrids and distributed energy networks. The fifth, enhancing operational and maintenance efficiency. By analyzing solar irradiance patterns, we can detect performance drops or faults in solar panels early. This leads to reduced maintenance costs and improved system reliability. In conclusion, solar irradiance prediction is a key factor that enhances both the economy efficiency and stability of core smart grid technologies, including renewable energy management, energy storage, demand response, and energy trading. Now let's take a look at how cnix's Pascal can contribute to this. The diagram you see here shows the system architecture in which Pascal is connected to data service platform. First, Pascal is trained using historical weather data for several years, obtained from meteorological administration. Then it receives forecasted hourly weather data from meteorological administration and transmits them to the pre-trained Pascal model. Once Pascal receives the forecasted weather data, it predicts the amount of solar irradiance that people can expect over the next 3 days, presented in hourly intervals. Currently, the system predicts only solar irradiance based on forecasted weather data alone. However, once it is deployed on-site, it also collects equipment data from the solar power system through data service platform. By transmitting this operational data to Pascal, it will be able to predict not just solar irradiance, but also actual power generation. Let's take a look at the demo. First, let me start by launching Pascal. Once connected to the Pascal server, you will see that pre-configured smart grid digital twin has already been registered. Currently, it is in a stopped state, so let's go ahead and run it again. Now let me briefly show you the dataset used for training. This dataset consists of 5 years worth of weather data from meteorological administration, specifically for my neighborhood, Namgu, Pohang. As you can see, solar irradiance is the target value predicted by the digital twin. I selected the related features such as cloud cover, humidity, wind speed, wind direction, precipitation, temperature, as well as the month, date, and time. I've already trained Pascal with this dataset. Now let's see how it works using a typical HMI. The table at the bottom shows the hourly real-time weather forecast from the Meteorological Administration for today, tomorrow, and the day after. Next, we activate Pascal to receive real-time data from the data service platform. Looking at the predicted solar irradiance for today at 1 p.m., it forecasts 2.2 megajoules per square meter. At 4 p.m., it predicts 1.7 megajoules. For tomorrow at 2 p.m., the expected solar irradiance is 2.5 megajoules per square meter, and for the day after tomorrow at 10 p.m., it's expected to be 2.1 megajoules. How about this? Pretty simple, right? Of course, predicting solar irradiance using numerical model is effective. However, one of the advantages of using SYNIX's digital twin, Pascal, is that you can flexibly add or remove parameters. This allows you to build a more adaptive prediction system that reflects rapid weather changes and the specific conditions for solar power system in different locations. All you need to do is to retrain Pascal with a new dataset. Thank you very much for watching this video.